This is our third topic, which is applications involving charged particles moving in a magnetic field. So, we have a charge moving in a velocity in the presence of both electric field and magnetic field, which is described by two particle in field models. Since it experiences both electric force and magnetic force, the total force is also called the Lorentz force. So, the total force acting on the charge is the total force, and we have a electric force and magnetic force, in which electric force equals to, going back sa first topic natin, which is charge times electric field, while the magnetic force, which is charge times velocity times magnetic field. We will have the total force acting on the charge, which is charge electric field plus charge velocity times magnetic field. And this is also called the Lorentz force. So, the total force acting on a charge, kasi iba yung charge, has a electric force and magnetic force. So we have a velocity selector. When the magnitudes of two fields are chosen, so the charge is equals to charge velocity times p. So ito yung electric force natin and magnetic force. So both the forces cancel. From this expression, we find that velocity equals to charge is equals to electric field over magnetic field. Why? Kasi maka-cancel yung charge natin dito. So, galing dito yung particle natin and magmo-move siya by force from magnetic force and electric force. And we can see na we have a uniform magnetic field which is going into the screen. No? If Q is positive, if the charge is positive and the velocity is upward, the magnetic force is to the left. So ito yung magnetic force to the left. And the electric force is to the right. Only these particles having the speed pass undeflected through mutually perpendicular electric and magnetic fields. The magnetic force exerted on particles moving at great speeds than that is stronger than the electric force, and the particles are deflected to the right. So, pag yung magnetic force daw is stronger than the electric force, ang particles daw ay mag-move to the left. So, left. Which is considerable kasi pag mas malakas yung force dito, mapupunta talaga siya dito. Pero pag yung particles daw mag-move in slower speeds, that is moving on the slower fields, slower speeds, it is deflected to the right. Kasi mabagal yung velocity niya, in which the force on electric field doesn't have a velocity, unlike the magnetic field. We also have a mass spectrometer, which is a mass spectrometer that a positively charged particles are sent first through a velocity selector and then onto a region where the magnetic field V sub zero causes the particles to move in a circular path and strike a detector array at point P. So we can see here that we have a velocity selector. So a beam of ions first passes through a velocity selector, then enters a second uniform magnetic field. So after niya magpass sa velocity selector is nagpasok siya sa magnetic field, and again, since this is a uniform magnetic field, yung path niya is helix. So nagpapunta siya dito, pero parang half circle lang siya yung path niya, and semicircle. And strike niya ang before striking a detector array at point P. So, if the ions are positively charged, pag positive yung ion, mapupunta siya dito sa left. Pero, pag the ions are negatively charged, the beam reflects to the right. So, dito sa right yung path niyang electron. Pag electron siya. So, dito siya. So, we can express this ratio as mass over charge equals to radius times magnetic field, which is v sub 0 over velocity, which is from the equation 29.3, which is the radius of the uh, circular path ng isang particle. So you can multiply the magnetic field, which is B, divided by velocity, and maka-cancel to. Putting the magnetic field here, or we can call it V sub 0, magnetic field V sub 0, according to the figure, and the velocity, which we will have it as mass over charge equals to R V sub O over velocity.